In this very short chapter, I'm going to show you how to load text files into your Apache Spark jobs. So far on the course, we've been working with hard-coded data in the form of a Java collection. Now, this is a very good way of working. It means you can concentrate on getting the structure of your Spark transformations and actions correct before you start worrying about external data files and so on. So this is great, but before long, of course, we are going to want to start working on some real test data. And in fact, it's very simple to load an external file. But the reason why I've given this a chapter on its own is you will have a small problem if you're working on Windows. So allow me to demonstrate. Let's change our code that we've written so far, and we're going to stop working with this hard-coded in-memory collection. So we can remove all the lines where we're setting up this input data. Instead, after we've created the Java Spark context, I would like to load in an RDD, and I'd like to initialize it using the data inside a text file. Well, it's very simple. So we'll be having a new RDD, and because we're reading in a text file, the RDD will be of type string. And I'll call this the initial RDD. And it's a simple case of on the Spark context object, you will find in there a method called text file, and we simply supply a path to that file. Now, almost certainly, if you're doing this in production on a real big data set, this will not be a local text file that you have on this machine. Because of course the input data, if it's big data, it's going to be too big to fit on a single machine's disk. For that reason, often when we're working with this text file method, we're going to be pointing to some kind of a distributed file system. So we can perfectly well in here supply, for example, a path to Amazon S3. That's Amazon's distributed file storage system. And on there, the files can be any size you like. Or this could be a path to a HDFS file. That's using the Hadoop file system. Now, what will happen when we load in one of these big files is very important to realize it does not load that text file into memory in this virtual machine. Otherwise, of course, we would have an out of memory exception immediately. Instead, what the driver will do, it will tell the nodes in the cluster to load in parts or partitions, as we've seen, partitions of this file. And all of that is contained inside the logic of text file. So it's really sort of beguilingly simple almost, in that to us, just writing a test program here, it is going to feel just like loading in a normal file. But when we scale up to production, it's just really a case of switching the location of that text file, and it will just work. Now, because we're still developing, we're still keeping things simple, we're certainly not going to be using S3 now. Instead, we're just going to use a local file inside our development environment. And I've supplied for you inside source main resources a collection of folders with some different pieces of test data that we'll be using throughout the course. But in the next chapter, we're going to be working in this folder called subtitles. So I suggest that we have a go at loading in this file called input.txt from the subtitles folder. Now, a quick way of doing this. Now, I stress this will not work when we go to a production clustered environment, but it will work for now. So we're just going to do the simplest thing that could work. So a quick way of referencing this file is to go src/main/resources, and then we have it inside a folder called subtitles, and then the file is called input.txt. And so that is going to load in that file, and that's going to split the file up into partitions, which will be represented by this new RDD. By the way, I've not shown you the structure of this input data, so let's have a look at that. And what we have here, in fact, is a subtitles file from Virtual Pair Programmers. It's from our Docker course, and it's every single chapter on the 2 Docker courses, in fact. So it's quite a big file. It certainly doesn't qualify as big data. There's about 40-odd thousand lines in there, so it's not massive, but it's certainly going to give us something interesting to work on. Now, I'm going to get you to do some really interesting processing on that in the next chapter, but for now, I just want to know if it loads in or not. What we can do is get this code compiling. First of all, we will need to import the Java RDD, and we can use this initial RDD as the input to this processing that we had before. We just need to remove the sc.parallelize because that just works with hard-coded in-memory collections. And on this initial RDD, we can do the flat mapping to get the individual words. I'm not sure the filter's relevant. Let's remove that line. So we're just going to get out each individual word from that subtitles file, and then we'll print each one out. All I'm interested in this chapter is, does the loading of the text file work? Before I run this, I've had a few problems running this because I kept getting typos in this path. I must have re-recorded this video about 8 times now, so I'm getting a bit fed up, to be honest. But I want to demonstrate that if I break it completely like that, of course what's going to happen is the code will crash, obviously. So there's an exception, and clearly nothing's going to happen because, as the exception here says, the input path does not exist, quite naturally. But you might be a little put off if I go a little further up. Now, this is only relevant for Windows users. You will also see that it says it cannot load this executable called winutils.exe. Now, actually, that's not a problem. The problem is, of course, the fact that the input path didn't exist, and we can fix that very simply by doing it correctly. So make sure this reads source main resources subtitles input.txt. Simple thing, and I managed to get it wrong many times. Now, if that's correct, you should find, I'm not going to do any editing here because I'm on Windows and this is going to be a little bit odd. Now, I don't know if you saw that, but there was definitely an exception flashing past. But even though there was an exception flashing past, can you see that the mapping does appear to have worked? I've got certainly very dirty data. This isn't sort of useful at all. But we've got on each line, it's the input data that's been split up at the spaces. So that looks good. And actually, if I scroll all the way to the top, it looks like I ran out of buffer space. So I can't actually see that exception appearing. I can fix that, I think, by right-clicking here on the Eclipse console for Select Preferences and go for and untick this Limit Console Output. Going to be a bit careful with this because if you really are running some big data operation, you can very easily run out of, you can cause an out of memory exception. Should be okay for this though. If I run again, I just want to catch that exception. What was it? So yeah, I saw it, and this time if I go all the way to the top, yeah, it's still saying it cannot load this executable winutils. But even though that exception happened, it then carried on and it ran absolutely fine. Now, it will only happen if you're on Windows. If you're not on Windows, then you can safely end this chapter now and you can go forward to the exciting next chapter. But if you are on Windows, this will probably concern you. Now, all that's happening is because the text file does support a Hadoop HDFS file system, there is some code in the implementation of text file which is looking for the presence of Hadoop on our system. Now, Hadoop doesn't exist as binaries for Windows, so it's not finding it. It doesn't matter because we're not using Hadoop at all, and as you can see from this, the exception does not cause the program to crash. It does continue. However, this exception is going to be very annoying, so there is a way of getting rid of this, and that is, as kind of hinted here, there is a program available, an executable called winutils.exe, which is kind of a Windows compilation of the Hadoop binaries. And it will at least give us the minimum amount of dependencies on your Windows environment to allow you to run this program without an error appearing. You can get this winutils.exe from this GitHub repository here, which is run by Steve Loughran. Now this person is, if I go a little further down, they assure us that they are a Hadoop committer. They're part of the Hadoop project. And they do this as kind of a courtesy to the community. And you can download that executable file from here and place that in your Windows environment. You don't have to do that because we've already downloaded this file for you, and you'll find it in the Practicals and Code folder under the winutils-extra folder. Inside there's a folder called Hadoop. Inside there's a folder called bin, and then the winutils.exe, and it's just a 106K, so it's not a very big file. Now what you need to do is copy that Hadoop folder to somewhere on your C drive, and I suggest actually for simplicity, in fact I've already done it for me, I've just put it in the root of my C drive right there. So that's not a full Hadoop, it's just this winutils. Then what we're expected to do is to set up an environment variable pointing to that folder. I think it's a bit awkward having to go into Windows and changing your entire environment for this, when it's much easier. Just at the top of your program here, we can set up that environment variable by calling system.setProperty, and the property, the key here is hadoop.home.dir, and then for the value, this is going to be the full path to that folder you've just created. If you followed along with me, then it's just going to be C:, and you can use a / in Java that will map to the \. It's easier to do it this way. C:/ Hadoop, and with that in place, if we run again, you should now see the program running with no nasty exceptions at the top. We've still got this warning, but that's not a problem. So loading in text files from a massive distributed file system is quite straightforward in Spark. There's just this one nasty little Windows problem, which is why I've given it a chapter on its own. Hopefully it's running for you. And in the next chapter, finally, all of this is going to come together and we're going to do really useful Spark job. So have a good break and I'll see you for that.